Hey everyone, welcome back to another lesson in MCV4U. Today we'll be talking about factoring and simplifying radical expressions. We'll start off with a few factoring examples that look at previously learned factoring techniques, and then we'll move on to simplifying some radical expressions. So let's look at this first example here. So if this first example is 25x squared minus 16y squared. So important to recognize what type of factoring you could use here. So here we see that 25x squared minus 16y squared is what we call a difference of squares. And so when we know that it's a difference of squares, we know that a squared minus b squared is equal to a plus b, a minus b. So here, what you need to do is you need to square root the first term, which is 25x squared, which will give you 5x. You need to square root the second term, which is 16y squared, which will give you 4y. And so your answer that you get here is 5x, which is your a value, plus 4y, which is b, and 5x minus 4y. So again, important to recognize these examples here. So here, the second question is 16x cubed plus 54. First thing you want to do is you want to see again if there's ever a common factor that you can factor out of these equations. In this situation, 2 is the common factor, then you'd be left with 8x cubed plus 27. And so now we can recognize that 8x cubed plus 27 is a sum of cubes. We know that when we have a sum of cubes, we have a cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared. Okay, so here we have 2. We see that if let's square root these, or let's cube root these two terms. So we cube root 8x cubed. That will give us 2x. And if we cube root 27, that will give us a value of 3. So here we now are left with 2x plus 3, and we have 4x squared. That's a squared minus 6x. That's a times b, and then plus 9. Again, you can factor this further if you choose. In this situation, we'll just keep it as that. Okay, the last example that we have here is 2x squared minus x minus 3. And here we are just going to use simple decomposition. Remember, we want two values that multiply to equal to a times c. In this situation, would be -6. And the same two numbers to add up to equal to, b or -1. Here we'll have 2x squared plus, and so -3 and +2 are factors that we're looking at. So we'll have 2x squared plus 2x minus 3x. Remember, these two are splitting apart that b value of -1, and then -3. So we want to find the common factor between the first two terms and the last two terms. And so if we factor out a 2x here, we'll be left with x plus 1. And if we factor out a -3, we will also be left with x plus 1. Then we can simply factor out the x plus 1. So we have x plus 1, 2x minus 3. Okay, so let's move on to a little bit more difficult problem here. It says 2x cubed plus 3x squared minus 11x minus 6 is equal to 0. So the first question you want to ask yourself is, can you factor by grouping? So if you can factor by grouping, it makes the question a lot easier. In this situation, if we look at our first two terms and our last two terms, there's no common factor that will be able to be factored out here. So if not, does factor theorem work? Yep. So we have to look at all our different factors or our possible roots. So write that down here, possible roots. So some possible roots we have are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1, plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, and plus or minus 6 over 2. If you notice here, plus or minus 2 over 2 is a duplicate or already listed, and plus or minus 6 over 2 is already listed as well. So these ones are already listed. So again, you have to see if these are a factor, and you can sub in these values to see if they work as a factor. So here, if I sub in value of 2, we see that we'd get 2 times 2 cubed plus 3 times 2 squared minus 11 times 2 minus 6. So we calculate that out. We get 16 plus 12 minus 22 minus 6. And that gives us 0, which is what we're looking for, which we see that therefore x minus 2 is a factor. Once we do that, we have to see what is left over after we factor x minus 2. So we write our 2 at the front, and we write the coefficients. So here our coefficients are 2, 3, negative 11, and negative 6. And we write down the 2. Now you multiply 2 by 2, and so you get 4. 3 plus 4 is give you 7. 2 times 7 will give us 14. Negative 11 plus 14 will give us 3. And 2 times 3 will give us 6. And negative 6 plus 6 will give us the value of 0. So we see here 2, 7, and 3 will be our values of our coefficients after we factor out x minus 2. So here, if we factor out x minus 2, we'll get 2x squared plus 7x plus 3 is equal to 0. And you can factor this further. X minus 2, 2x squared. So using decomposition, plus 6x plus x plus 3 is equal to 0. X minus 2, factor out here, we'll factor out 2x. So that we left with x plus 3. And we'll factor out just 1 here. And we'll have left with x plus 3 is equal to 0. Same factors, x plus 3 here, and x plus 3. And so here we have x minus 2 plus 3, 2x plus 1 is equal to 0. So we have a couple of values for x. We have x is equal to 2. That's our first answer. We have x is equal to -3. That's another answer. And here we have x is equal to -1/2. And that's our third answer here. Yep, so again, just to review here, again, when you look at these types of questions, can you factor by grouping? If you cannot factor by grouping, then you want to look to see if factor theorem works. Okay, so let's move on to the second part of this lesson, which is simplifying radical expressions. So if you recall, we see here square root a times square root a will give you square root a squared. Remember, a square root a is also equal to a to the power of 1/2. So really what's happening here is it's a to the power of 1/2 times a to the power of 1/2. And if you use exponent rules, you will get a value of a. So here, same thing, a to the power, this also looks like a to the power of 2 to the power of 1/2. That is also equal to a. Okay, so square root a times square root b, that gives you square root a times b. You can combine the values inside the square root. And here we are simply using distributive property. So you have square root a times square root a, square root a times negative square root b, square root b times square root a, square root b times negative square root b. That will leave you with a minus square root ab plus square root ab minus b. Negative ab, square root ab, positive square root ab, those cancel out. So here you'll be left with a minus b. Finally, c multiplied by square root a multiplied by square root a, that will just leave you simply with c times a. So as we work through these next couple of questions, make sure to keep these rules in mind. So the process of changing a denominator from a radical number to an integer is called rationalizing the denominator. So here, example one, to simplify each by rationalizing the denominator. Again, so we are taking our 2 over square root 5, and our denominator is square root 5. And so we're going to multiply both the numerator and the denominator by square root 5. And so that answer will give us 2 square root 5. Remember, square root 5 over times square root 5 will give us 5. And so the same thing here. In this situation, our radical is square root 2. So we're going to multiply both the numerator and the denominator by square root 2. So here we will have 4 square root 2 over 3 times 2, which is equal to 4 square root 2 over 6. Then we can simplify this. That will give us 2 square root 2 over 3. Moving on, so now we're looking at what are called conjugate radicals. So an expression such as square root a plus square root b has the conjugate square root a minus square root b, and vice versa. So for each expression, state the conjugate radical. So here we have square root 2 plus square root 3. So the conjugate radical would be square root 2 minus square root 3. Same thing here. 2 square root 5 minus 3 square root 7. Our conjugate radical would be 2 square root 5 plus 3 square root 7. So if we look at this, when we're rationalizing the denominator, so here we're going to use what we just learned in terms of the conjugate radical to help us rationalize the denominator. So 3 over 1 minus square root 2, I'm going to multiply that by 1 plus square root 2 on the numerator and the denominator. So here, remember the 3 is multiplying to both the 1 and the square root 2. And same thing here. The 1 is multiplying to both the 1 and the square root 2, and the negative square root 2 is multiplying to both the 1 and the square root 2. What we'll be left with is 3 bracket 1 plus square root 2 over 1 minus 2. And here we have 3 bracket 1 plus square root 2 over negative 1. And there's two ways you can write this. Again, here you can leave it as negative 3 bracket 1 plus square root 2. Or if you want to distribute inside, then you can write it as negative 3 minus 3 square root 2. Right, so let's look at this question B here. So same idea that we just did. Again, we're going to look at the conjugate radical. In this situation, I'm going to multiply by 5 square root 2 minus square root 3. And here we have 5 square root 2 minus square root 3. Again, we want to multiply each of the components to each other using our distributive property. So here we have 2 square root 3 times 5 square root 2. That will give us 10 square root 6. We have 2 square root 3 times negative square root 3. That will give us 2 times 3. We have negative square root 2 times 5 square root 2. That will give us 5 times 2. And finally, we have negative square root 2 times negative square root 3. That will give us square root 6. Right, so that's all over 5 square root 2 times 5 square root 2. And so here we see that it's going to be 25 times 2 minus 3. And so if we simplify that, it'll give us 9 square root 6 minus 16 divided by 47. So let's move on to rationalizing the numerator. So we're doing the same thing here, except instead of multiplying by whatever the radical is in the denominator, we're multiplying by whatever the radical is in the numerator. So here we're going to multiply by square root x minus 4 and square root x minus 4. So here we'll be left with x minus 16 over x minus 16 multiplied by square root x minus 4. And we see that here, the x minus 16 will cancel out. And so we'll be left with 1 over square root x minus 4. Same thing with this question here. I'm going to multiply by the conjugate radical. Here's square root x plus 9 plus 3. And then the bottom is square root x plus 9 plus 3. So here we'll be left with x plus 9 minus 9 over x times square root x plus 9 plus 3. We see here that the 9 and -9 will cancel out, and the x and x would then therefore cancel out as well. So here we have 1 over square root x plus 9 plus 3. Okay, finally, our last question here. We have square root h squared plus 10h plus 16 plus 4 over h. So here, multiply by square root h squared plus 10h plus 16 minus 4. And we're going to do the same thing on the bottom as well. So h squared plus 10h plus 16 minus 4. Here, we'll be left with h squared plus 10h plus 16 minus 16 over h times square root h squared plus 10h plus 16 minus 4. Here we see that our 16 and -16 cancel out. We can factor out an h from the remaining h squared plus 10h. So we have h bracket h plus 10 all over h times square root h squared plus 10h plus 16 minus 4. Here we see that our h values cancel out. And here we'll be left with h plus 10 all over square root h squared plus 10h plus 16 minus 4. You can choose to simplify what's inside the square root, which will be h plus 10, which will be h plus 10 over square root h plus 10, or h plus 8, h plus 2 minus 4.